Good morning, good afternoon, if you're at a different time zone. Happy Friday. So we'll record the content as usual. We'll send it out, but I'll get started, guys, just because it's a Friday. Some of you guys are eating lunch or maybe having happy hour. So the topic we'll talk about is augmenting your revenue growth management and augmenting your revenue strategy with knowledge graphs. And we have the pleasure of having my colleague Rudy Agovich here, who's been in this space for a while. And so I'll let Rudy introduce himself. I'll do a quick introduction and we'll get right into the content. So Rudy, go ahead.
All right, well, welcome everybody. My area of expertise is AI and machine learning. I've been heavily involved with knowledge graphs for the past 7 or 8 years, helping larger organizations implement them. I'm the co-founder of a company called Reliancy and also the co-founder of a company called Clarity Data Insights that is focused on building products or an intelligence platform on top of graph databases.
Thank you, Rudy. And my name is Armin. So those of you that have known me, attended prior Revology Analytics webinars, I founded Revology Analytics a couple of years ago. I've been in the RGM/data science space for a while. And so what we specialize in is basically building revenue growth analytics solutions for companies in-house. So we basically insource these capabilities for companies so they're sort of self-reliant and they own most of these capabilities. So guys, I'll jump right into the content. So we'll talk about sort of knowledge graphs and how to augment your revenue growth strategies within the context of CPG, consumer products industries, right? But really, it applies to all industries as you think about it, right? It applies to manufacturing, distribution, retail, right? And so we'll start with talking about sort of some of the data challenges that exist within CPG. We'll also allude to some of the findings that we've had from a revenue growth analytics maturity study that we did with about 150 commercial leaders. And then Rudy will take it over and talk about knowledge graphs. We'll do a demo based on simulated data just to kind of give you a flavor of how this actually looks and what sort of insights you can kind of generate with knowledge graphs. And then lastly, really exciting, we'll talk about kind of fusing knowledge graphs with LLMs, right? And actually driving some unique insights using LLMs. So let's talk about real quick about analytics maturity, particularly as it relates to sales and customer growth analytics, right? We've done a study of, again, nearly 150 commercial leaders. And so one of the things that we found is when it comes to customer analytics, marketing optimization, sales optimization acumen, but three out of 4 companies, they sort of rated themselves as kind of medium to low maturity, right? This is a very statistically honest sort of a feedback from companies. And so typical questions that we've asked from CPGs and other industries like manufacturing is, for example, when you make a pricing decision, is it actually driven by robust diagnostic and predictive analytics? Fairly basic stuff, right? And so scores kind of range from 1, rarely, 3 sometimes to 5 consistently. What you notice is CPG led the pack, but it's still sort of in that sometimes range. Well, sometimes I use data and predictive analytics, sometimes I don't. Sometimes I rely on gut and heuristics. Manufacturing was notably bad, right? It's like 1.6, which is rarely using this. When we ask the same thing about promotion effectiveness, right? Again, some fairly meek scores, right? 1.8 for manufacturing, 3 for CPG, which is sort of that average, below average level. Despite a lot of the times these companies spending 10 to 25% of their gross revenues on promotions, right? They just simply don't have the analytical backbone to do these things systematically and do it in a way that actually drives ROI. When it comes to marketing effectiveness, right? About 3 out of 4 companies almost said they can't effectively quantify the return on their marketing spend, right? And that was quite evident with manufacturing, where only about 17% of the companies said they have a good sort of mechanism to actually quantify the marketing spend. And CPG, 1 out of 3. Again, these are really, really low numbers that need to improve. And so when we talk about knowledge graphs, right, this is really pinpointing the idea that CPGs, again, consumer products companies, along with many manufacturers, right, they're incredibly data rich, but they're very insights poor, and very insights poor when it comes to sort of interconnected, multidimensional, actionable insights, right? Those are incredibly hard to come by. The dynamics of the marketplace is always changing, new competitor entrants, different promotions, different retailer strategies. These companies are dealing with different types of data. Many of you, right? You have structured data, you have unstructured data, you have structured data for your competitors, for your retailers, you have unstructured data for your product reviews. CPGs, if you happen to be working in the consumer products industry, also deal with different go-to-market strategies, right? Sometimes you rely on a three-tier distribution system. You sell to a distributor who sells to a retailer, who then sells to an end consumer. You may go direct to retail, or you may go direct to consumer, right? And you have most of the larger kind of mid to large size CPGs tend to have all three models, right? And different sort of ranges. And so the couple of things that are really important for companies to understand is, certainly supply chain and the movement of product, right? But then the second and third pieces are understanding how my pricing and promotions are working and what sort of influence they have, and quantifying that influence, right, on your company and the distributors and the retailers. And then also, what is the competition doing, right? And how should we react to different competitive actions? And so when we talked about the disparate sources in CPG, right, this is sort of an example. Again, some of this kind of mimics what manufacturers may deal with or what distribution deals with. And so, you tend to have, again, transactional data, right? Your typical sort of sales profitability inventory data comes from your internal systems. You have distributor sellouts. Sometimes it's syndicated data, sometimes it's direct point of sale feeds, right? You have promotional data, how much investment you've given, what were the terms of the promotion, how long did it last, things like that. A lot of times, again, it comes from internal systems or maybe some third-party trade promotion management system. You have retailer sell-through data, again, syndicated, Nielsen, IRI, NPD is also another big player. Competitive data, right, on your competitive brands and products, and what are they doing in terms of promotion and a pricing strategy. You may have retailer ads, and you have unstructured data, right? So we talked about product reviews. You may have customer feedback through customer service type data. You may have social media mentions. And so the issue is CPGs, and again, most manufacturers and distributors, are really kind of most traditional companies, are really good at doing analysis and maybe one or sort of at most two or three of these things. But even the stitching together of that information tends to be really sort of complex, manually intensive, and takes a long time. And so the crux of it really comes down to companies organizing this data with sort of an operational mindset, right? Like it's really siloed. Let's put this transactional data here. Let's put the syndicated data here. And it's really not designed, again, to give insights, actionable insights that inform the commercial teams on a particular strategy near real time, right? Because extracting that knowledge and extracting that optimized sort of commercial action, pricing strategy, product assortment, et cetera, takes a really, really long time. And to give you an example of sort of what it looks like for real world, just imagine, again, you work for a consumer products company, and there's a sales decline, right? One of your competitors launched a new product in a particular category. And so the thing that you want to understand, because executives are asking about, is, well, how does our sales performance change, right? If we actually sort of do some price skimming or your price investment to actually counter competitor B's product launch. How does that differ? How does our performance differ if we do a 10%, 20%, 30% discount? And so again, in the traditional analytics view, think about that graph that we just showed you earlier, right? You have to do a bunch of things, right? Pull data for competitors, pull transactional data, bifurcate your transactional data by promotional discounts, right? Maybe do some retailer analysis from syndicated data. And so all these activities take a long time, and even the best data science teams or the best analytics team, it takes like a couple of days to answer fundamental questions that should inform your revenue strategy, right? Whereas with knowledge graphs, with the proper design of that data, it actually takes minutes. Why? Because all these elements that we reviewed on the prior page, they're all interconnected through relationships, right? And they all have key data elements and properties, et cetera, associated with them. And Rudy will kind of give you guys a really good overview of how that's happening under the hood. And so Again, I wanted to give you guys a sense for some of the data challenges and the promise that knowledge graphs hold. I'll stop sharing the screen, and maybe Rudy, I'll turn it over to you. You can share it and kind of go forward with the presentation.
All right. Oh, thank you, Armin. So with consumer packaged goods, we have kind of a pretty complicated landscape as far as data goes. I mean, most organizations have a complicated landscape. And so the question is exactly how do these knowledge graphs help? So we will go through an overview here, and then later we will talk about how this ties in with AI and more advanced kinds of analytics methods. So what exactly is a knowledge graph? With a knowledge graph, data is represented in terms of nodes and edges. So in this case, for instance, we have a distributor that is related to a retailer through a works with relationship. And one thing to note about knowledge graphs is that they're more like a conceptual thing. A knowledge graph is not a physical, it's the idea of how you decide to organize knowledge. It's not the physical storage medium. So moving on, well, why do we even want to care about knowledge graphs? Well, if you think about enterprise data, a lot of it you can think of in terms of paths and journeys. So you have a customer has a journey associated with it. You have sales, there's a journey associated with sales. Even if you look at products and whether or not there's warranty issues that arise once the product is out in use, there's a life cycle or a journey associated with a product. So once you realize that enterprise data can be thought of as a lot of different paths, and you start fusing those paths, a graph kind of naturally emerges. So yeah, and a graph, so here, what we have here is an example of a path that would be kind of product related. It starts out with the product being manufactured, it's sold presumably to a distributor, and then resold by a retailer, it gets used, and then eventually there's a review for it. One thing that, you know, these types of knowledge graphs can be used for is, well, first of all, to organize data that we have in various stores. Like this might be something that comes from a ERP system or, you know, like CRM system. So it allows us to organize that, but then it also allows us to add unstructured information, like for instance here the review. It might be a review in terms of, you know, having 2 out of 3 stars, but there might also be a text component to that basically where the person describes this product in detail. So you have different kinds of information that it gets stitched together into paths and graphs. So that's in essence the idea of knowledge graphs. Now, knowledge graphs are not something that's completely new. It's well, you could say it's an established technology. In particular, in the world of, so if you look out there, there's a lot of examples of existing knowledge graphs that you might not think of as a knowledge graph. Like, for instance, Wikipedia. The knowledge in Wikipedia is organized using a knowledge graph, so that if you're looking at a particular entity, or say you're looking at a president and it tells you that the president has like 3 kids, there's actual nodes and relationships behind this data that relates the president and those 3 kids. And so that's one thing. Like, this is to say that knowledge graphs are not some kind of a hyped up technology that is new, but it's really established. And particularly within AI, this has been used for decades. So there's a more formal way of thinking about knowledge graphs, which is in terms of ontologies. So an ontology is basically, you can think of it like a schema for a graph. So in this example here, we have, you know, kind of like a rule indicating that the retailer sells a product. So this would be something you would find in an ontology, which basically tells you what kinds of information you're going to be capturing in the knowledge graph. So an instance of this where we have here Walmart sells, wipes. So wipes is being a product. This would be the knowledge graph, and this orange portion of it would be the ontology dictating what the structure of the knowledge graph should be like. Now, when it comes to ontologies, there's a formalism around that. So this isn't just like hand wavy type of thing. There's like a theory behind it, and then an ontology also will have a set of what they call axioms or rules, which dictate how new relationships can be established. So that type of a knowledge graph that's based on an ontology has been used for decades and can be used for reasoning, because the ontology tells you how you can evolve the graph. This is just sort of a little background that, like this isn't something we're getting out of thin air. Now, knowledge graphs have been around for a long time. And as I mentioned, a knowledge graph is really more a conceptual idea of how you organize knowledge. It doesn't dictate how that gets stored. You could create a knowledge graph and store it in a bunch of text files. Now, that may not be very efficient. So when it comes to businesses and enterprise, knowledge graphs have seen kind of an emergence starting around 2010. And the reason for that is the development of something called native graph databases. So these are databases which can natively store paths, allowing you to traverse them very quickly. So imagine a graph where you have billions of nodes, and then being able to follow paths within that graph very efficiently. So the first native graph database that was introduced around 2009 was Neo4j, and that is still the market leader in the space. And in the meantime, over the since 2009, 2010, this type of technology has matured quite a bit, and a lot of businesses are using it. And like if you want to kind of draw a parallel where you have deep learning and GPUs that enable that, in this case we have knowledge graphs with scalable graph databases that made that that enabled the use of knowledge graphs within businesses. So what is the difference between this knowledge graph approach and what everybody is doing with their traditional database systems? So one of the big problems is that companies don't really, they think of data as this thing that sits behind your ERP system, your CRM system, the operational thing that then gets thrown into a data warehouse. And so you have lots of data, but data is not necessarily knowledge. It's not necessarily useful. There's, a lot of it is actually just not relevant. And so, a business stakeholder might come along and they'll have a question. And typically what happens, an analyst will go into the data warehouse and then they'll figure out, okay, so to answer this question, what kinds of data sources do I need to connect? And, how do I answer it then? And so because of that, that's the typical process is, you dump the data into data warehouse, you then, every time you have a question, you need to stitch together the data to answer that question. And then, it's kind of all over again whenever there's a new question that has not been addressed yet. And that leads to, a lot of inefficiencies, and, it can take, there's companies where it takes up to 2 to 3 weeks to get a dashboard that answers a question that's, because usually when you have business stakeholders and there's a new question that comes up, they want not just the answer, but maybe something that allows them to monitor that. And so it's not uncommon to take even up to 3 weeks to get a deliverable like that. The key difference with the knowledge graph is that there is a knowledge engineering component that's involved at the very beginning. So before you start asking questions or start answering questions, you ask yourself, what is relevant to me? So what kinds of knowledge do I want to capture about how we do business, about our company? And so that's one key thing that a lot of companies are not doing. They're not thinking about data in terms of analytics first or AI first. And this question about what knowledge matters to us only comes up further down the line. And so the benefit of this is when you ask that question up front is that you organize your data, or this time around it's actually knowledge, it's useful data. You organize it in just the way that's relevant to you. So if I'm looking at a sales opportunities, I'm going to extract exactly the steps that are relevant for me when I'm doing sales. And so once you do that, you'll have a graph that's really relevant. And the process here would be that you pull in those data sources into that structure. So you wouldn't be extracting all of the data, you would only be extracting the relevant data, and then you perform the analysis. And the benefit of this is that you have the relevant data at your fingertips. And so as questions come, you don't have the need to reconnect the dots every time. So that's, like why it speeds up insights significantly, and why it matters. Moving on, let's see, is there like a question here?
Yeah, I think there's one question, Rudy. What are you interested in? Hypothesis-driven might evolve over time. How do you account for this in a knowledge graph design? i.e., do you need to go back to the drawing board if some of these hypotheses change over time?
Well, there's a way. So you would definitely, if it's something that that evolves over time, then you do need to account for it. So like this, if you don't, you will have to go back to the drawing board. And so how you do it, that's going to be, we're going to get into some examples of, this process of putting together a knowledge graph. And that is very, very problem specific. And we have one example that deals with time. So maybe we can revisit this later. One other thing I would say is that there's a level of flexibility with some of the knowledge graph approaches that will allow you to evolve what matters over time. So even if you're not modeling time explicitly. And so we'll get into that as well. Let me just, this actually, the next few slides are touching upon that. So moving on. So we have established that these knowledge graphs, they allow us to capture data in sort of a journey path type of way. And if you think about enterprise data in that sense, then that opens up the door to look at data very differently. And so you may ask yourself, well, why not just do that with my data warehouse? I could organize data and just do that. The answer to that would be that traversing a path is a very expensive operation in a relational database. And let me clarify that a little bit, because so here I have a visual, and typically the reason why it's expensive is because it involves join operations. So if you have a table that has millions of rows, in order to extract a path that's like, say, length 7, you would need to join that table with itself 7 times. And so that becomes very inefficient. Now, the example I have visualized here is a little bit misleading in that regard, because you may ask yourself, well, Rudy, what are you talking about? If I have activities like this, wouldn't I just order them by time and I'll have my, sequence of events? That is actually the misleading, like I kept this just kind of for illustrative purposes, but it might actually be good to change the example here. So just to clarify this, the idea, the part that a SQL database has trouble with is, imagine you have a graph, and within this graph, you ask yourself, what is the shortest way, or what are all the various ways that I can get from node 1 to node 2, where these 2 nodes. So let's say we have 2 entities. One is a marketing asset, and one is a transaction where I made a purchase. And I ask myself, what are all the different ways to get from this marketing asset to a transaction? So typically what you would do in a SQL database is you would, like if you were to represent a graph, you would maintain a table that has all your edges in it. So from, there's one hop is from A to B. And then, so like you have all your hops defined, all the edges are defined in a table. And so that's why traversing a path in a SQL database would mean you now have to stitch together the hops, which amounts to doing a join on the table that keeps your edges. And so that is the reason why representing a knowledge graph in a sort of traditional SQL database becomes inefficient. And why, if you are able to store these kinds of paths natively, you will get a significant performance boost. And this is not to say that there are other graph database implementations that don't rely on a native implementation. So there's those out there as well. They're just not as efficient as the native ones. And one thing to note here and highlight is this distinction between, we talked about knowledge graphs and then we switched talking to the graph about graph databases. So they're two different things. The knowledge graph is how we decide to represent knowledge, and then the graph databases is the physical storage of it and what enables us to work with that knowledge graph efficiently. So there are different kinds of and one other thing I wanted also to note here, because some people will maybe get annoyed about it. So there are people called ontologists whose job it is to engineer these kinds of knowledge representations. And like for them, there's a very formal definition of what a knowledge graph has to be. It has to be tied to an ontology. There's a more loose view of it, where you could think of a knowledge graph that is not necessarily tied to ontology, but something called a labeled property graph. So if we talk about Neo4j and most recent databases, you're going to hear the term knowledge graph used a lot. A lot of the times when people use that term, they don't necessarily think about the knowledge graphs in the formal sense that they're tied to an ontology, but rather in this more loose sense. Moving on. So one of the benefits of these newer types of knowledge graphs, graph databases, and this isn't the case for every type of graph database. There are two types of graph databases, or there are multiple, but the two main ones are one what is called a labeled property graph, and one is called RDF. The RDF graph databases are more rigid, and the labeled property graphs are a bit more dynamic, and they're a bit easier to work with. And so in particular with these labeled property graphs, like Neo4j is one example of that, you are able to define new fields and new relationships kind of on the fly. So what was a question before is, what if what matters to you changes over time? As you are adding new nodes, the way this is set out is you could infuse new relationships. So let's say I have a new customer, I add a new customer. Now this customer has new relationships that I didn't have before. And so this would be difficult to do with the sort of more formal view of what an ontology is, because then you would have to evolve your ontology. Whereas in this sort of more loose view of a knowledge graph, you can do that. And so the graph database itself facilitates it. So you can do it. You can infuse. You could literally have two customers, and each of the customers has like different fields in it. So there isn't like a strict enforcement, and that makes sense when the main purpose of your graph database is to enable analytics rather than some kind of rigid data management, because you want to be flexible and dynamic, and you can that's one of the benefits from an analytics standpoint. The other part we've already mentioned, it allows you to fuse data of different types. A lot of the times people think of database records and text as sort of structured and unstructured, but one key part that is also relevant here is as you are deriving insights, you have the flexibility to infuse the insights into the knowledge graph. So you're enriching your knowledge with derived knowledge. And so there are no like set rules that it just has to be data that comes from your data warehouse, and that that's it alone. So I'm going to get back. See, there's more questions here. I'm going to get back to that as I get down further. So I've just given you a little bit of an overview of what conceptually what a knowledge graph is, and about graph databases, what kind of capabilities they provide. Reality of it is, you can think of this, and it will get into the example, and then it will make more sense once you see it visually if you've not been exposed to a graph database before. But a graph database, it provides immediate value to companies that usually implement it, because once you connect the data, just knowing how things are connected and being able to trace what happens in an organization already provides value. It allows for knowledge to be managed, speeds up insights, as we already talked about, and there was this, the question about evolving the graph. Yes, you can evolve the graph over time, but you have to be very careful about how you do that. And you are able to ask additional questions that you may have not thought of when you constructed the knowledge graph. It provides some interesting, things along the way. Like, for example, once you've constructed a knowledge graph, you can create recommendations from the knowledge graph without having to use any kind of AI machine learning methods, just by aggregating the graph structure in the past. Like, for instance, if we have sales cycles and we are in a particular action, we can look at past actions and the likelihood to get to a sale, and then basically recommend the next best action that is most likely to lead to a sale based on purchasing, sales patterns in the past. So those types of things make a graph database really valuable for analysts, because you can get things out of it very easily and quickly. Graph databases are valuable for data scientists, as we will talk more about later, and they're valuable for business stakeholders because you get insights really quickly out of them. Now, this is just very generic talk about knowledge graphs, and let's get back a little bit to the actual use case. Let's just see what I'm missing here. Okay, we'll get back to this. Do you know of any method to maintain all non-data relationships?
Yeah, do you want to address the question real quickly, or should we go to the mock-up and then we'll answer at the end?
I think it'd be, because I'm going to be running out of time. Let's keep these till the end. So when we talk about, I can just talk to this very briefly. So all known data relationships. So let's just put it this way. You do not want to maintain all known data relationships in a graph database. You want to maintain only those relationships that are going to serve your purpose. So if you're constructing let's say you're constructing a knowledge graph with the purpose of building, like large language models are popular right now, and you want to answer specific questions about your business, you would only maintain those relationships in there. Now there are ways in which you maintain that. So when this is kind of a question about there are tools that allow you to basically, well, first of all, like I'd say that the way you would construct this, the most desirable way to construct it is not necessarily to hit the source systems. So whoever designed your data warehouse, they would be querying against the source systems, and then ideally you build your knowledge graph against the data warehouse. So you extract the relevant information that way, and so you're not slowing down the source systems. And I don't know if the question relates to the source systems or the data warehouse, but that would be the ideal setting. But if you do have to go against the source directly, the way the integration is implemented for data warehouses is there are tools that listen for changes. So when a new record is added, when something changes, then events fire and you only act upon those changes. That's typically how integrations with a data warehouse are implemented. And if you wanted to connect your knowledge graph directly to the sources of information, that would be the approach you would take. Again, you would never want to update all the relationships in your data. Because then it kind of defeats, then you kind of have like a data warehouse again. Let's get back, and then if there's time, return.
Yeah, maybe as you're pulling up the demo, Rudy, somebody else was asking, would Spotfire fall under the knowledge graph approach? So I think I'm 75% sure in my answer, but I believe that you're talking about TIBCO's kind of data visualization tool. They do have a graph database. So TIBCO, like many other kind of data providers, have their own instance of graph database. Spotfire, I believe, is just the kind of visualization tool. So it's not a knowledge graph per se.
So I'd say there's a number of products that have graph databases under the hood that are not, evident or visible to you. It's like, and then once you start looking at the graphs, you're probably gonna be asking yourself. So, for instance, one product, Adobe Analytics, which is used for within companies to look at website traffic patterns and whatnot. They allow you to look at paths within web sessions, for instance, and create reports off of that. And so you can, by looking at their UI, you can tell they have to have a graph database beneath that to work. But it's not something that they kind of advertise as part of the product. So getting back to this presentation, so there's an array of use cases. Once you think about these paths in an organization, it opens up the door for a whole array of use cases to be tackled. Any pricing and promotion, there's a number of them that are tied to pricing and promotions and consumer packaged goods, like product performance, competitive analysis. But then there are more general capabilities like marketing enablement, sales enablement, e-commerce personalization, monitoring of assets, product warranty analysis, training enablement. Now, these are all kinds of things that apply to a wide variety of businesses. Obviously, they're relevant to CPGs, but they're applicable really widely. So, enough talk about conceptual things. Let's look at some examples. We'll hopefully make this more concrete, and then we'll get back to how that relates to AI and more advanced types of analysis approaches. So I have created two types of examples here that I want to showcase. One has to do with journey mapping, and one has to do specifically with analyzing pricing and promotions, which is kind of very tied to consumer packaged goods. So let's take a look at this first example. Journey mapping really means, as I mentioned before, well, let's think about all the different journeys that happen in an organization, and let's think about ways of how we can capture that. So let me bring up my window here. Just bear with me for a moment. I have to figure out where my graphs went. All right. What are we looking at here? So let me open up a new window here. So this is an example of this is mock-up data, example of Neo4j database. So we talked about various things about nodes and relationships. And so let's just look at what the data looks like in here. So we'll start out by clicking on account. So this would be an account would be a node that comes out of Salesforce. And if I hone into this, I may see, like various kinds of information that has been pulled in from an account record from Salesforce. So if I click on an account, I'll get, let's see, I have 3 contacts under this account: Roy, Megan, Stephanie. And if I click on them, again, I'm going to see data that is actually coming out of Salesforce. And there's relationships here that, so this is pretty simple data that, most people would be familiar with. So we have Roy works for this company. And again, all of this is sort of made up data. And if I click on Roy, it opens up a, more nodes, opens up 3 sales opportunities that are tied to Roy and are tied to this sales representative, Emily Johnson. So again, this is graph representation of data that most people are kind of familiar with from Salesforce. And now if I click on one of these opportunities, it expands a bunch of nodes. I'm just using this for illustration purposes here, but usually you wouldn't use this Neo4j for visualization. As you can see, as the amount of data grows, this gets unruly pretty quickly. So I'm just going to, I have to arrange these nodes in a way that is not cluttered. So let me just do that very quickly. And I'm not going to spend a lot of time doing that, but the point is I've started out with an account. I had 3 contacts associated with this account, and then there's 3 opportunities tied with a particular sales rep, and now I've just expanded an opportunity, and now the opportunity is a sequence of events. And these would be kind of the opportunity stages, which would be defined for my business. That would be something that's relevant to me. So what we've done here is we've just kind of drilled into sales data. The way it's typically represented is tabular form in Salesforce, and we have it here as a path. And in similar ways, so this is Salesforce. Now you can do this similar thing with your marketing data. There's tools like Marketo that are used for managing campaigns. You can use a similar approach for your website traffic. Maybe the company runs an e-commerce website where they actually sell things, or might be just kind of information about products. So now if you think of it like that, there's multiple of these sub journeys that comprise a bigger journey for the customer. And you could incorporate in this also the product journey, but let's just switch to an example view here of what what customer journeys might look like. I'll just hone into this and kind of go. And again, there isn't a right or wrong as far as how this should be represented. So that's one key thing. So this is actually a simplified view of a customer journey, and it only makes sense for this mocked up company. Now, the way you would want to go about doing this is you would want to construct a journey that's relevant to your company. So that's the knowledge engineering piece. And so here is an example of how a customer journey might look like. At the center, we have a node that represents the journey. Then there's a green node. And before we were expanding these nodes and we were looking at the contact, which in this case is the customer. And now you'll see here multiple kind of colored subpaths. The blue subpaths, they represent sales opportunities. So there's, looking at this, there's 3 of them. And we've seen 3 in the previous example. So there's one here, and this is not connected properly, but I think it starts here and then goes down up here. And then there's a 3rd one here. The orange nodes, they represent transactions. So you can have timestamp associated with each one of these events. And so you do have a way to kind of order them chronologically of how they happened, but this is giving you additional structure. And so the red nodes, they would represent marketing data. The yellow nodes, they would represent your website. And so if you hone in and you look at it, it says this is multiple page views. And then here we have marketing events, visited booth, downloaded some kind of an asset, opened an email, again download, and so on. And the way you kind of paint a more complete picture is you then tie all of these things to the individual assets, products, and that the company is using. So if I'm clicking on a view here, this will actually going to show me what it is that I'm viewing. And so in this case, it's a marketing asset. If I click on another one here, I actually may see a web page. The UI is messing with me here. It's not opening. So that would be one example of a representation. Okay, this looks like it's frozen. Oh, it's responding. Right, my window is frozen. Well, good thing I've gone through the main part of it. So if you click on the individual events, you can tie them to the web pages, to the marketing assets. And so this gives you kind of, like that interconnected set of paths that we talked about. And so why is it relevant? How you would use it? Well, if you think about it, like if sales optimization is, and all this comes back to revenue growth. If sales optimization is what you want to do, you can be looking at successful sales patterns. What leads to a short sales cycle? What is most likely to lead to a purchase? Looks like this is responsive again. Is it? So part of the issue with this visualization is it sometimes freezes. So you got that complete picture, and then you can ask other things like, when should I be using a marketing asset to improve my outcomes? Or if I'm looking at a website, I have, this is literally your session data, and you could be looking at personalizing things. So what content should I be showing to increase engagement, to increase conversions? So there is a lot of richness in here and a lot of different things that you can do when it comes to revenue growth. Let's just now dive into an example of how you actually work with this data. Let's see if I can bring this back to life. Not sure what's going on with it. I hope my other windows work. Zoom. Okay, so I've prepared a number of queries to show you how you actually work with this data. Let's go down. So here, these graph databases, they usually have their own ways in which you can interact with them. Cypher is one such language. It's kind of like a SQL for graph databases, a simplified way of querying them. And the querying, I just wanted to illustrate how this querying works and the simplicity of it. So let's say if I wanted to get a marketing, return marketing assets, this would be what the query would look like. So these rounded brackets, they are intended to represent a node. And so if I click on one of these, it will give me the actual asset. So that's one sample query in this language called Cypher. And if you're a data analyst, this is what you would use to get the value out of the graph. Now that's how you would query a single asset. Now, if you wanted to get a path, let's say here we want an asset that has been viewed as part of a journey, and I only return one. This is kind of what that query looks like. You can see the representation of the query is kind of mimicking the visual of the graph. So, and you could specify relationships here as well. But this is kind of, this is a pattern. I'm looking for a pattern. And that's one of the things that is important to note here. I'm not just connecting the data. By doing this, it allows me to look at patterns of behavior, at patterns of success. And that's what I'm kind of illustrating here is my query isn't just, get me data. It's actually specifying a sequence of actions or activities that I want to be matched. Yeah, let's move, one step further in this. So let's say I want to slightly extend this path that I'm querying, and now I'm looking at an asset that has been viewed as part of a journey that also ended in a transaction. Okay, so that now we're tying marketing assets to transactions, and that's what it takes. This literally this one line. And think about if you had this sitting in 4 or 5 different tables in a data warehouse, how easy that would be, like how much complexity there would be just to pull in the data. So that's one thing you can do. And now let's move on, in this progression. And now in the model that I have, things are sold in terms of a bundle. So a bundle, will contain the product and whatnot. So now I have just extended the path to include the bundle, so the actual product that has been sold. If I click on the bundle, it will say something like Aeroflow, again, made up product. But so what we've done here is we've just taken a marketing asset, and I'm not telling it what marketing asset, if you can see here. I'm just saying, let's look at a marketing asset and let's connect that to a transaction and to a product. And there's a path. So what can I do with this? Why is it useful? Well, let's take this one step further. I could, let's see here. Done here. I think I haven't done anything here. I have done something here, which is I removed that limit of 1. So by removing the limit of 1, what I have done is I'm looking for all the asset interactions that then led to a purchase of Aeroflow. Okay, so now I'm tying, previously I told you I wasn't looking at a particular asset, and it was for a reason. Like I've just now extracted up patterns from this graph that suddenly might start giving me useful information. And like what does that all come down to? Well, if I take this query and I summarize it, I tell it, give me all the assets that lead to a purchase of this product, and then order them by the amount of money that was made in those transactions. What I get is a listing of the marketing asset by how much money was made. And what is that? Well, this you can use as a recommendation. Like what we've done here, literally in the 4 or 5 steps, we have created an asset recommendation methodology, if you will, where now if I'm showing this product, I could literally be using an approach like this to ask the graph what asset to show. And it's done by looking at historic data and patterns of how assets have been used without relying on AI and machine learning. So that's the part that it's really valuable for data analysts. We're going to be running over time, so I will kind of try to speed things up because moving really slow here. So this is the example of journeys. And again, journeys are applicable across the board. This example is meant to be illustrative. In the reality, journeys journeys might be interconnected. Somebody comes to a website, they do a marketing activity, then they connect to sales. So the reality of that picture is not as clean as what you see here. It gets more complicated. But that's why it's really important to carefully design this and engineer it so that it actually can be useful. Let's move on to the other example. I've created another set of graphs that I wanted to show you. So here, the consumer packaged goods example. This is a very interesting use case because it's not necessarily about journeys. You have, in this use case, you have manufacturers, you have distributors, you have retailers, and then they sell the product. the manufacturer, if they introduce a promotion, they don't know if the retailer or the distributor will pocket that promotion or will actually pass it on to the consumer. If they introduce, well, basically anything they do, they don't have direct control over it or direct visibility. There are sometimes data agreements in place, but usually it's third parties like Nielsen that provide the data. And so you have some kind of a, think of it like a very detailed report about every grocery store you can think of, like on a literally on a location level, how much was sold of each product that you can hone in, but then also more generic type of data that would be kind of market trends for selling cleaning wipes. The challenge within this space is that you have data that is different and that it's coming from different places, and you need to make inferences across multiple of these dimensions. So I just want to show you one way of how you could go about this and where a graph then can end up being useful. So here's an example of like a way of capturing this type of data. So let's say you start out with a brand. In this case, let's assume it's Clorox. And if I'm Clorox or manufacturer like Clorox, I will have transaction data on my things that I sell to a distributor. So here, like there's a transaction that gets generated, and they are interacting with Cisco here being a distributor. Again, this is all made up data. Within the transaction, there is a promotion that was applied, 10% off promotion. There's also the transaction is tied to a region, Northwest region. The distributor works with a retailer, Walmart in this case. And then the way this data is organized is really driven by those Nielsen reports. So we assume that Nielsen reports are coming in on a weekly level. So there are data collection events that happen weekly. And so for every retailer, we will have sales observations and promotional observations. That's what Nielsen data will tell you. And so that's kind of what that looks like. Let's see if I have expanded everything here. Yep, I haven't. So the reason I'm expanding this is sometimes the data will also include customer segments. Old people buy this much versus young people versus middle-aged people. So you may get this kind of customer segmentation, which also comes out of those reports. And so what this does is basically taking that report and converting it into a graph structure. And so I even have here, the green nodes are the segments. I have the sales, I have the promotions, and then all of this is tied to a product. They're cleanup wipes. And so, typically, this is the type of data the CPGs use, and they'll create, they'll be encoded in SQL, they'll write, some kind of filter queries, they'll able to, to change all sorts of values to, and this is an oversimplification. I have only one retailer. In reality, you would have hundreds of retailers tied to this product. If I did that, you wouldn't be able to visually see anything here, but that would be the reality of the data. And so now, okay, so how do I go from this to actually leveraging the graph to be more useful? Well, you can think of, like tying the product to a product category. And so here, for example, we now have, rather than just having one brand, Clorox, we now have 3 brands. The other ones, I don't even think they correspond to the actual company. Shiny Co. and Bright House, they each have their cleaning wipes, and they each have their collection events tied to them. The collection events are indexed by time. So there was a question before about time and dealing with time. I think this is an interesting use case because this isn't about tracking an asset in an organization necessarily and kind of following that path, which is kind of easier to wrap your mind around. If we have here an analysis that's multidimensional and we're trying to leverage the graph to get to the various pieces more effectively. And so, like you basically, what we're saying is we can go from this. We start out with a structure that captures those reports, and then we move towards something like this, where now, rather than having, one, so this is one product, this is my company, but then there is a product category, and to the product category, there are other products that are tied, and each of the products will have its own collection path. And, then we have other things going on. Like in this path here, we have 3 retailers that are depicted, that are, that we have data on. So one is Kroger, one is Costco, and one is Target. And then a retailer could be selling more than one product. So in this case, we have Target that's connected to both of these products. Now, the reality of this data would be highly more complex, meaning a lot more retailers, like every retailer will have hundreds of products. So, but what this does is just an illustration of like literally just this one node that connects the products. Now allows you to tie in what's happening with your organization with what's happening across all these other brands. And so for CPGs, I will not construct a query for this because it's going to get complicated, and it's a more complicated use case. But this basically, what allows you to do is I can look at the promotions that I've put in place, and I can check, are they trickling down to the consumer? I can check, like how is that affecting market share and those types of things. But then I can also contrast that with what my competitors are doing. Like, okay, so there's a time period here where there's a promotion in place. That's the 2 blue dots. I can then look for other competitors that also had a promotion in place, or periods where I did not have a promotion, but I did have a promotion, and then try to explain why, the performance of the product. So this is just to visually explain how you now tie the dots together, and you're able to answer a lot more questions. Now, these get, complex, these questions, and it's not feasible to create a report for every one of these things. And so typically the CPGs, they will live sort of in a constrained space down here. If there's a question that comes occasionally, it has to be a one-off. And this is really enabling. Now, I kept this use case a second because it's a bit harder to wrap your mind around. And because if you look at it, it looks more like it's, like the events, they seem like they might be more constructed. Because we have taken a report that comes in on a weekly basis, and we made an event out of that in our knowledge graph to capture it. And the other thing to note here is, like we have this data from Nielsen, there could be other data coming in. So the collection event might be getting data from other companies. There might be even data that comes from agreements with these retailers. And the other thing that you can capture here, if you look at this particular company here, ShinyCo. ShinyCo works with Target through a distributor, but it works directly with Kroger and Costco. So it allows you for that flexibility because, as Armin mentioned, these companies, they can operate in different ways. They could be working with a distributor, they could be working with the retailer, and that creates headaches when you want to do analysis. So that's the second use case. I have spent already too much time, so I'll try to wrap up the remaining slides. Just a moment.
Rudy, just maybe a couple of words on the prior slide. Guys, I want to make sure that the folks don't get kind of wrapped up in the visual of the knowledge graph or the visual of Neo4j. That's just more of a sort of an illustration of how things are tied together. In reality, these things are so complex, and there's millions of potential kind of nodes and things like that. But the real power in this comes in the ability to answer multi-dimensional questions in real time, like literally within seconds. So the example that Rudy gave, how do our promotions influence our sales, competitor sales, vice versa? Run predictive analytics on competitor cross elasticities, or understanding profit pools within an industry, right? When you looked at, when Rudy showed you guys like the distributor node, kind of also being part of the journey, understanding how profit pools change by season, by product during certain promotional times, how much of your promotional investments are distributors passing on to end customers. And so this type of relationship-based structure allows these insights to be generated at a fraction of the time that you would otherwise be able to do through traditional kind of data and analytics. Go ahead, Rudy.
Right. So, now there's a lot of options out there for graph databases. As I mentioned earlier, Neo4j is sort of the market leader. There are a lot of products that, all of these that I have on this slide, they scale to billions of nodes. So mature products that you could use. Neo4j Tiger Graph is a big one. I know that United Health Group used Tiger Graph to build like the biggest knowledge graph in healthcare. ArangoDB is interesting. They combine text, different types of databases like text and graph. And even SAP has one. Coincidentally, like I've talked to a number of their big clients, and most of them, they don't seem to be aware that SAP has a graph database implementation. SAP HANA is an in-memory database where the nodes themselves, you can look at them either through a tabular view, kind of relationally, or through a graph view, which is kind of interesting. Now, so the way I've structured these two groups is most of so the databases on the left side, they might have like a free version, community version like Neo4j or ArangoDB you can use. But if you want to get to scale, you have to pay. So it's commercial at scale. And even if they might ask, say that they're like open source, you still can't get those scalability features within the community versions. And then on this right side here, we have databases which are open source but also free to scale. So OnGDB is from Graph Foundation. It's actually a fork of Neo4j when Neo4j was kind of truly open source. So it's like an enterprise version of Neo4j from a few years back. Well, they had issues in the courts and whatnot, so they're not allowed to mention Neo4j, but that's one option. But there is other ones that are actually even more, I'd say, powerful. Huge Graph was developed by Baidu, and Nebula Graph is another one. And what makes these kind of interesting is that, it's open source, but then you can use it to scale, to billions of nodes. And obviously, most companies, when they implement them, the next question is, who's going to manage this? Who's going to maintain this? And so in a lot of cases, even when the free aspect of these graph databases ends up being interesting, that they kind of tend to shift towards products that have some kind of managed solution out there, some kind of support that they can rely on. So these are the graph database options. Now we get to knowledge graphs and AI and how that's related. We've already touched upon ontologies and that being a key component of AI, but the reality of it is really it's not just that it enables AI. It's really an important part of AI because knowledge representation is part of AI, and it's a very important part because if you have done any AI implementations, you'll find that the problem isn't necessarily with the models. Like there's a step before you do the modeling called feature engineering, where you try to figure out what's relevant to my modeling problem. And a lot of the times that step ends up being far more important than the actual model that you ran, because you need to give the model what's relevant. And so if you are piecing together a graph of what's relevant to your domain, then you're already doing a lot of work that can then be leveraged for training AI models. And so like that, this idea of putting knowledge as something strategic first that you should be thinking about is really key. The idea of using AI and machine learning over graphs is also not new. Like this has been done for decades. The reason I know is because my PhD thesis was partly about this topic. So there's various things you can do with graphs. One thing is you could predict nodes. Given a graph, predict nodes, so it would be like the next best action if the action is a node. You could predict edges. So if the edge, say, represents whether, when a customer views a blog, then, will the customer view a blog would be an edge. You could predict entire, classify structures. So you could say something like, these are my successful sales cycles. These are the not so successful sales cycles. Let's just classify what's happening in sales in buckets and say, this is most likely to be successful. So that'd be one area where you could apply. The other one would be, let's just look at what the customer has done so far, and let's classify the intent of the customer, not just based on some tabular information, which is what I usually do, but instead based on this rich graph representation and every interaction they have ever done. So, and you could do that for intent prediction. And then lastly, you can use it for graph-based customer segmentation. Again, where you're looking at the behavior of the customer, of what happened to the product, and then you segment into pieces. Now, that is something that's not new. What's more recent is sort of it's not that recent either, but over the last decade or so, deep learning has become sort of a leading approach in a lot of things AI. And there are graph neural networks that you can apply for these types of purposes that we've just mentioned here. So predicting nodes, edges, structures, even the type of architecture that is used in large language models exists for graph structures. And so there's some example packages that can do this, include PyTorch. There's one called DGL that can run across various platforms like TensorFlow, PyTorch, whatnot. There's one by DeepMind called GraphNets, and then TensorFlow has one. There's one called Spectral, which is again based on TensorFlow. So this started out as like 1-2, initially frameworks. There's a whole sea of them now, and there's a lot of tools that you can use to work with graph data. Which is interesting, because with graph data, you have the ability to infuse different kinds of inputs, and it's not just this sort of tabular thing that people usually do in AI machine learning. Now, knowledge graphs have seen a lot of popularity lately with the emergence of large language models, and the reason for that is precisely because they help you organize knowledge. One method with large language models in particular that has been popular is something called retrieval augmented generation, where the user asks a question of the large language model, you take the question and you basically convert that question into a vector representation. So you do a semantic search. You say, okay, let's take this query and find documents that are most similar to what I'm asking about. And then you take those documents and give them to the large language model up front, and then you say, oh, but by the way, here's my question. So it could be something like, oh, I want to know if, let's say, you're talking to insurance and you want to know whether your roof will be covered when there's hail. Let's say something like that. And so the question, when you ask it, ideally would go in and retrieve the document that contains this information, give it to the large language model, and then the idea is the large language model should look that up. Now, one idea here, also like one way in which knowledge graphs end up being really useful, is that in that search, people realize this is actually not so simple. How do I find the most relevant? So the most difficult aspect of talking to the large language model, you leave to that search component. And so then it makes sense to make your information easily retrievable. And so if you want to build a large language model that, provides support to a call center, the person at the call center, when a question comes in, the knowledge needs to be organized so that you can easily get the relevant information. And that is something you can do much easier with a knowledge graph than with a traditional database. We've been involved in projects where companies have given us a database for large language models. And so what happens is there's business logic that is a layer of business logic and how information is stored. And so they'll say, oh, we want to retrieve this thing, but to retrieve it, you have to look at like 10 different places, connect that, and then get the information back. And so that makes it a lot more difficult to get the retrieval working properly, and even for the large language model to interpret that. So the idea here is to augment this sort of semantics vector-based search with a knowledge graph retrieval to get sort of the relevant nodes. And coincidentally, companies like Neo4j have added support for vector-based search. So this is literally to support large language models and this sort of retrieval augmented generation. So you can you can ask to get the relevant documents, and then you can also go into this knowledge graph and have a vector representation of the nodes and get the relevant nodes from the knowledge graph based on similarity to the vector. So it's basically a merging of vector search and knowledge graphs. So that's one big way. And then there's really a whole lot more work here that's happening, and there's this realization that you can actually fuse knowledge graphs and large language models in a sense that, like to reduce hallucinations, to guardrail how they work, and like to have a way to fuse business data with a large language model more reliably. But the other way is also true that a large language model can provide value to a knowledge graph, because sometimes the knowledge is kind of static. And if you were talking before about potentially adding new nodes and edges, you could leverage the large language model to expand the knowledge graph and add insights into it. So it's sort of a symbiotic relationship and a very active area of research. So I apologize for going over time so much. As far as conclusions go, I think kind of made the point here that the CPG data is very complicated and multidimensional, and because of that, it exhibits paths and patterns in the data structure. So it's actually lends itself to knowledge graph knowledge graphs very well. Like as we've talked about, knowledge graphs have the potential to improve quality and speed of insights, improve competitiveness, and enable AI applications. And so organizations are well advised to model their knowledge that they have and go beyond this operational view of their data. So thank you, everybody. That's all I had.
Rudy, thank you so much for spending the time with us and dropping all this knowledge. Hopefully, for the handful of attendees that have stayed on for almost about 25 minutes later, thank you so much, guys, for staying with us. We'll have this recorded. We'll have the slides available, so we'll send it out. If you have any questions, please contact us. Hopefully, you've gotten a sense for the power that this technology and this approach holds versus traditional analytics and sort of answering key revenue growth, strategic questions and insights. So appreciate the time, guys, and then reach out to us anytime. Enjoy the weekend. Goodbye.